Technology Petronas. Our group consists of 2 chemical engineering students, which is Eim anak perempuan Ewan and Muhammad Aliff Najmi bin Rosli, 1 electrical engineering student Muhammad Harith bin Abdullah, and 2 mechanical engineering students Siew Ke Hui and Muhammad Zaki bin Aznam. The supervisor for our group is Dr. Muhammad Zaki bin Abdullah, and this is the presentation for design concept of our project, which is called atmospheric water sink. So what is atmospheric water sink? Atmospheric water sink is a machine that is being made to allow people to wash their hands and allow them to sterilize their belongings. The idea behind this project is to promote good hygiene habits among citizens. During the pandemic, it is important for everyone to practice hand washing because it is one of the effective ways to prevent the spread of germs and viruses. The atmospheric water sink are using the concept of atmospheric water generator, which extracts water from the humid ambient air as the water source. The water produced will then be used for the hand washing purpose. We also add another feature to our project, which is the UV box. The UV box will function as a device to sterilize personal belongings such as handphone, key, wallet, and money. So this is our problem statement. Low accessibility to hand hygiene facilities is one of the issues why people do not always wash their hands. Because of the COVID-19 outbreak, people do not prefer going to public washroom to just clean up their hand, as the place is more contaminated with germs and bacteria. Next, sanitizing using hand sanitizer is a very common practice nowadays, but excessive use of alcohol-based hand sanitizer will increase the risk of eczema and risk of irritated skin. People not only use hand sanitizer to sanitize their hands, but some people also use it to sanitize their personal belongings. That's why we created atmospheric water sink to try solving the above problems. There are 2 objectives for our project. The first objective of our project is to revolutionize access to clean water and better hygiene. The second objective is to produce an alternative sanitization service for the community. For the Sustainable Development Goals, our project mainly focuses on 4 SDGs, which is SDG 3, Good Health and Well-being, SDG 9, Industry, Innovation and Infrastructure, SDG 11, Sustainable Cities and Communities, and SDG 12, Responsible Consumption and Production. This is the drawing for our atmospheric water sink. It is created fully using AutoCAD software. The dimension of this machine is 1 meter long, 0.7 meter wide, and 0.96 meter tall. There is also a curvature on every edges with a radius of 30 mm. So this is the front view of our project. At the top side, we can see that this machine has a faucet which will work with a sensor, a sub container, and a sink with a size of 500 x 400 x 100 mm. And then there is also a UV box sterilizer with size of 300 x 150 x 100 mm. This size is only enough to fit small belongings such as phone and wallet, but not as big as a laptop. Then on the body, there are vents on each side to allow air to come in and out from the machine. There is also a water level indicator which will show the water level in the tank. And this is the back view of atmospheric water sink. At the back, there is also another vent with a size of 300 x 400 mm. There is also a drainage exit for the sink and water tank inside the machine. At the back of the faucet, there are 2 light indicators. One is red and one is green. The green light will light up if the machine is operating, and the red light will light up when the machine is not operating. This picture is the front view of our internal component. From the top, there is a water tank with a capacity of 40 liters. Then at the middle, we have an evaporator, condenser, and expansion valve for our refrigeration system. The condenser and evaporator both size 500 x 400 x 300 mm. Next, there is also a fan at the evaporator which will suck air into the evaporator, and a fan at the condenser to remove the heat. At the bottom side, there is another water tank with a capacity of 40 liters. Then there is a 3-stage water filtration system which will ensure the water produced is clean and safe. And this is the back view of our internal component. At the bottom, there is a compressor with 4 kW of power. Then we have a water pump which will flow the water from the bottom tank into the filtration system and then into the top water tank. And then we have the drain hose for the sink and the emergency drainage hose. The emergency drainage hose is a system which will allow water to flow out from the tank in case excess water is produced. Lastly, we have the UV box. The UV box uses two UV lights, which will be placed at the top and the bottom of the mesh. The UV light we use is UVC light with a wavelength of 280 nanometer. The reason why we are using UVC light is because it is the only UV light that is strong enough to kill the germs. The UV box operates with a button and a slider. When the button is pressed, the box will close automatically and then the UV light will turn on. And then, when the button is pressed again, the UV light will turn off and the box will be open.
Raziq. Now we're moving on to the methodology part. Now, for the exterior design, we choose stainless steel as material for the sink and faucet. This is due to its high corrosion resistant quality, and not only that, it also resistant to fire and heat, allowing it to resist scaling and retain its strength. Moreover, the material is easy to clean and maintain. Top surface, we choose the ceramic as the material. Ceramic is considered harder than conventional metal material. The corrosion resistance is also an important aspect. It has low density while having extreme hardness, not to mention that it is cheap in price. For the exterior body part, we use high density polyethylene or HDPE due to its lightweight yet strong and durable characteristics. Its chemical and weather resistant quality making it long lasting as well as cost effective. For the piping system and water tank, we choose polyvinyl chloride or PVC as material. The material's characteristics are light, tough, and durable. It also corrosion and weather resistance. Its non-toxic characteristic making it safe to use for water transport, and moreover, it is cheap and cost effective. And for the refrigerant tube design, aluminum has been chosen as the material. The material is good heat conductor, allowing heat exchange to occur. The material is durable, lightweight, and corrosion resistant. It is available cheaper than the copper material. Moving on to the water filtration system. Our filtration system has three different stages. The water generated will go through the first filtration stages, which is sediment filter. Sediment filter will provide the mechanical filtration as shown in the diagram. It captures and removes the particulates in order to protect the other filter. This will also affect the taste and the appearance of water. Then, the water will go through the second filtration stage, which is carbon filter with activated carbon. The pore size distribution of the carbon filter will allow the absorption with the organic compound in water. The activated carbon coat will interact chemically with the organic molecules. This filter attracts most of the contaminants by absorption or ion exchange. This filter is also responsible to remove the organic compound from water such as chlorine and chloramine. The final filtration stages will be the reverse osmosis membrane or RO membrane. Its job is to remove the inorganic impurities such as total dissolved solids, which cannot be done in the previous stages. It filters these contaminants down to 0.0001 micron, so it can filter the molecules heavier than water such as sodium, fluoride, and other dissolved minerals. Moving on to the health, safety, and environment aspect, we identified that the hazard of this project to be caused by the UV light radiation. Thus, the light radiation need to be turned off or protected when turned on by providing the cover to avoid exposure to the user. Now, I pass the floor to Aim.
Thank you so much, Aliff. And I'll be talking about refrigeration cycle. Refrigeration cycle works in removing heat from low temperature object, which is refrigeration, and rejects it at a higher temperature. There are four major parts and components, which are the compressor, condenser, expansion valve, and lastly, the evaporator. All these four components are connected together through connecting pipes to construct a complete basic refrigeration cycle. This cycle can be divided into two parts, which is the low pressure side on our left and the high pressure side on our right. The refrigerant, which is also known as the coolant, will flow through all the components in the pipes. For our products, which is AWS, atmospheric water sink, which extract water from the moisture of air, we will be more focusing on the evaporator, where water is generated and collected there. First, let's start with the compressor. Compressor pressurize and compress the low pressure vapor refrigerant inside the compressor chamber. According to Gay-Lussac's law, the pressure of a given amount volume is directly proportional to the temperature. So when the refrigerant is compressed by squeezing the vapor tightly together into high temperature, it will simultaneously increase the temperature. After that, the high pressure and high temperature vapor refrigerant will leave the compressor, and now it enters the second component, which is the cold condenser. According to the second law of thermodynamics, heat will flow spontaneously from a hotter to a colder body. So when the hot refrigerant vapor enters the condenser, it will start releasing heat to the surrounding. And at the same time, the refrigerant will condense from vapor form into liquid form. A fan is installed to liberate the latent heat past the condenser coil to prevent it from overheating and make sure that the process of condensing will still going on and continue. Now, the refrigerant that coming out from the condenser, which is in a high temperature and high pressure liquid form, will enter the expansion valve. Expansion valve helps in facilitating the change of higher pressure liquid refrigerant from the condenser to a lower pressure gas refrigerant in the evaporator. The molecule of the liquid refrigerant will be expanded, causing a drop in the pressure and the temperature of refrigerant, hence causing a change in the state. It converts the refrigerant from liquid form to saturated mixture, which including liquid and vapor that is cold, chill, and low temperature. The refrigerant will now leave the expansion valve and enter to evaporator. This is where the water is generated and collected. The low temperature and pressure refrigerant in the coil will start absorbing heat from the surrounding. A fan is installed to circulate and draw the warm air into enclosed space and blow across the coil in the evaporator that carrying cold, chill, saturated mixture refrigerant. This causing the effect of condensation, and this is where we collect our water in the water tank. Thank you so much, and I'll pass it to In for water flow.
Thank you, Ke Hui, for the great explanation on the refrigeration cycle. Now, I'll proceed the presentation by explaining process of water flow and the limitations of atmospheric water sink. How can we turn atmospheric air into clean and usable water? Sounds unique? Now, let's go through the process of the water flow and water production. Freshwater scarcity is growing day by day. We have seen cities like Jakarta and Cape Town witnessing water shortage over the last decade. We will cover very interesting and unique technologies that are helping combat the growing water scarcity around the world. Firstly, we should understand that even in the driest, the humidity level is never zero. Hence, some amount of water is present and the AWS process can occur at any level of humidity above 0%. However, humidity level more than 50% is required, especially to ease the process of water production. The energy source for running this AWS is electricity, which will move the fan and increase the air flow rate. The use of electricity allows a degree of control and consistency on the output, to provide the same amount of water production. The air will then pass through the evaporator that cools the air and surrounding it into the condenser coil, which will cool the air below its dew point. Thus, the precious drop and drop of water is producing. Next, the water in the condenser will flow through the water filters to remove impurities, including the dirt, and produce clean water for daily usage. However, there are three limitations of AWS discovered in terms of portability, the number of daily users, as well as the volume of the water produced. Since the energy source to run AWS is using electricity, thus this device required direct power to run, which means it should be plugged in to an outlet, thus making it unportable. Additionally, AWS must be installed under the roof or indoor for safety purposes to avoid an electrical shock. Next, AWS will produce approximately 11 liters of clean water per hour, which is approximately 264 liters of water daily. Assuming 5 liters to be the average amount required for one user for drinking and washing hands, AWS can help up to 53 users per day. That's just too great. Moving on to the next slide, another limitation of AWS is the low water level, where the water volume only occupied 20 to 25% of the tank capacity. Thus, this limitation will cause an insufficient water for daily usage. However, to tackle this limitation, our group have designed the AWS with a sensor that will detect the water produced, and when the water level is below the desired amount, the sensor will detect this situation and will turn on the mechanism to increase the airflow rate by increasing the speed of the fan so that the rate of usable water produced will increase. I'll pass to Harith to proceed with the last part of our presentation. Thank you.
Thank you, Eim, for explaining on the process of water flow. During our design, we utilized two types of software, which are AutoCAD and Tinkercad. AutoCAD is used to design a three-dimensional perspective of the device, whereas Tinkercad creates a circuit simulation of the device. And in this product, the only circuitry needed to simulate is the sensors. So let's move on to the simulations. This simulation uses Arduino Uno R3, a battery, a motor, and an ultrasonic distance sensor with a few basic components. Now if you look closely, the green circle represents the water level of the tank, and this can be indicated by using LEDs. Now if you move the water level between 20 to 85%, the motor fan runs at 1000 RPM, which is standard for a fan. However, when the sensor detects the water level below 20%, the motor increases its speed to 3000 RPM, allowing more air to flow into the machine. This causes an increase in the condensation process. What if the water level overflows? Well, the sensor will pick up the water level above 85%, causing the motor to immediately stop the airflow, followed with the compressor to shut down, stopping the refrigerant flow. In this case, we set the green LED as a deactivation for the compressor. The red LED, however, represents when the compressor is running. Next, we will talk about the power usage of the machine. In AWS, the power supply only applies to the fan, the pumps, the UV light, the compressor, and finally the sensors. From the combination of all of these systems, it is estimated that in a day, the machine runs at 50 kilowatts hour. And this assumes if the machine runs from 9 AM to 9 PM, which is 12 hours. That amount is similar to the amount of power used in a day by a local water dispenser, such as Koei. Moving on, we survey the community on their feedback for our design by using Google Form. Included with their opinions on our goals, objective, and our price if it is reasonable, and from 115 responses, they seem quite satisfied with the project. We asked them to rate on our final design, our objective, and our working principles. And as you can see, a majority of the responses rate our product as excellent. Among the 4 sustainable development goals, we asked the community if the machine contributes to that SDGs. As always, a majority of the response agreed with what the machine can bring to the 4 SDGs. However, among 4 of these, it seems the machine aims more towards SDG 9. How to prove it? We can see that SDG 9 has been voted the most from the survey. To be honest, initially our design was in a rectangular curve form. From the survey, many have suggested what shall be improved. Some say reduce the size, the faucet is far from the waist, and some even say that there is too much space around the sink. We take this response into consideration and ended up with a new sleek design of AWS. With the empty space, we add in a water level indicator on the left side of the sink, and an indicator if the compressor is running next to the faucet. We also add in a logo at the front panel, and surrounding it is an aqua blue skin to represent the color of atmospheric water. So, let's summarize what we have learned today. For atmospheric water sink, the machine takes in moisture from the air and condenses it to water by the process of heat exchange at the evaporator. The water is then filtered and stored in a tank for later use. So when this faucet sends a human hand, the stored water will then pump out into the faucet where users can use the water for their hygienic purposes. Speaking of hygiene, the right hand side of the sink represents a UV light box, and this UV light box disinfects pocket items where you place for a duration of 30 seconds. With this kind of machine, we can place it anywhere, whether it is in an institution, shopping malls, the outdoors, the stations, as long as the area has a power cord and humid enough to condense air. So, let's talk about the robustness of this machine. Since we improve our original design to a more modern form, we can see that the rectangular base surface of the machine improved the product to be more sturdy and firm. Not to mention the uses of hard plastic as the side panel to prevent unbreakable panels when applying force, such as a kick or a punch from the user. Finally, all circuitry components such as the UV light, the indicators, and components within the machines are shut tightly to prevent water from splashing onto it, making it waterproof. Of course, we don't recommend placing this in an area without a roof, since we believe the seal can only withstand up to a liquid rating of 4, which is splashes. In the end, I do hope you have a clear understanding in our design concept, and if you have any question arises, feel free to ask. Thank you and stay hygienic.